All right, let's get to reviewing here. 1 week from today is your first quiz. So I want to make sure we got all these down pat as we move on here. Circumference formula. Let's start off there. Circumference formula. Look back in your notes if you don't have it. 11, circumference. 11s. I don't know how we pick new numbers and we still don't have everybody. 1. Pi times the diameter. Good. Length of an arc in degrees. So length of an arc. How do I find the length? Not the measure, the length. How long an arc is. 13. How long an arc is. Yep, good. Got it. Measure of the arc over 360 times that circumference, pi d. Good, Lucy. Measure of the arc. Where do I find this value if it's not on the arc? All right, if it's not actually on the arc in degrees, where else could I find it? Measure of the arc is always the same as 14. I don't know where is that radians, degrees? I'm not too sure. Measure of an arc. As in this arc is so many degrees because this was measure of the central angle. All good? Questions? All right, moving on. All right, help me out. Circle K. Boom, what's so great? 1, tell me something else. K, George.
Center point.
Center point. Good. Tell me how to draw a radius, KS. 13, radius, KS.
A segment with endpoints like on the center of the circle and the outside.
Perfect. One endpoint's got to be on the center, other point somewhere on the circle. KS. Diameter, GH. 17, diameter, GH.
It goes to the center point, and the two endpoints are on either side of the circle.
There you go. Got to go through the center, G and H on the circle. And then finally, chord WV. 15, chord WV. 15, going. 4,
What was the question?
chord WV.
It just has to go from one side to the other.
Can it go through the center?
Yeah.
Yep, that's okay. Diameters are chords. All right, questions. And going back for Friday now. Friday's class. If I have degrees in front of you and I say, could you please convert it to radians, what are you going to multiply that degrees by? So let's say we have 120 degrees. 120 degrees, and I want to turn it into radians. What are you going to multiply the 120 by? 18?
Pi over 180.
Good. Pi over 180. Is that something you need to memorize? Shouldn't be, because where's it found? Formula sheet. That's on the back of your packet, which I will give you on the quiz next week. Do I want the decimal when you times by pi over 180 in your calculator? Nope. What do I want it in terms of? Pi. Leave the pi in your answer. All right, let's go backwards now. What if I have radians and I want you to in degrees? Radians in degrees. 5 multiply by 180 over pi. Now look, let me give you two versions here. 2 pi over 3 radians. You guys multiply it by 180 over pi, and the pi's would cancel out. Sometimes, though, if I give you 2.5 radians, multiply it by 180 over pi, will the pi's cancel out here? No. Best thing you guys can do, just put it all in your calculator. 2 pi over 3 times 180 over pi, and the calculator will cross them off if they need to. So just put it all in your calculator. Homework last night or over the weekend. Any questions? Anything with the clock question there? Because I threw another clock one, I think, on your quiz next week. Anything converting? Going? Nothing at all? Okay. I still want to see it, even though I gave most of you guys enough time, but let's just say, I don't know if some of you took advantage of it or not, so I will take a look at it. So. Some of you guys might want to take a look at the answer key, because some of you guys don't even have that last question close to correct. So, FYI, it was 240 degrees for some of you. FYI, just saying. That's why I put answer keys up. You guys are going to, and I'll keep saying, a few of you guys are going to get a wake-up call next Monday. Wake-up call. All right, here we go. I'll even though most of you probably took a little decent set of notes already, I still want to go from the top. Let me go back to my review I did with you at the beginning. This right here, this formula, length of an arc. You can only use it if the measure of the arc is in degrees. Well, we learned a new way to measure an angle on Friday. How else could I measure an angle other than in degrees? 7? Do we have a 7? How do we 14? Nope, not even that. What's that?
14's right there.
Oh, I thought there's 2 classes I don't have a 14 in. So what's the other way to measure an angle other than in degrees? That was our big topic on Friday. There's another way to measure radians. So hey, if I say this angle right here is, I don't know, 2.5 radians, can you use this formula? No, you can't use it. Everyone see that? You can't plug in 2.5. It's got to be in degrees. So we need another formula that says, how do I find the length of an arc if I have radians now? And here's the formula that you probably saw in the video already. Theta equals S over R. Theta equals S over R. Let me go through each piece right now. S, that's your arc length you're trying to find in most cases. Arc length. R should be pretty familiar. That is radius length. And then you have theta. That's where your angle measure goes. All right, but instead now, you don't put degrees there, you put radians. So that's the angle in radians. All right, angle in radians goes there. S is your arc length. Okay, so here we go. Let's take a look at our first one. Find me how long this arc length is. What's the angle in? Tell me the units the angle's in right now. This is in degrees or radians, my angle. 1, degrees or radians, George? Radians. So I know this formula I've been using all unit long is no good. It's got to be in degrees. So I want to let you guys know you have 2 choices right now. You could take the pi over 3 and convert it into degrees. Did we do that all Friday? Take pi over 3 and convert it, and then use the formula. Or you can use this new formula. I want you guys to have choices. All right? I'm not saying you have to know that formula I put up on the board. You can take pi over 3, convert it to degrees, and use the formula we've been using all unit. All right, that's fine if you feel more comfortable doing that. I'm going to show you how to use this new formula. Theta equals S over R. Okay, here we go. What is my angle in radians? So I can plug that in for theta. Angle in radians. 17, angle in radians. Okay, so everyone ready? Pi over 3 equals arc length S, which is what I'm asked to find, S, over radius length, which is 17 again? 5. So everyone see what I just plugged in there? Angle in radians equals S over R. How do I solve these, by the way, for S? There you go. Let's cross multiply now. So you cross multiply. I get 3s equals, cross multiply on the other side, 5 pi. How do I get the 3 out of there? Because I got to solve for s, remember. 7. 11. Good day, good day, good day. 14. Divide each side by 3, and I gave you rounding directions, everybody. Rounding directions, it says to the nearest hundredth. $17, nearest hundredth when you get it.
5.24.
Yep, 5.24 centimeters, the length of the arc. So am I making this clear that you could use this formula or take pi over 3, convert it into degrees, and use the other one we've been using over 360 times pi d? We're all good. You decide where you want to go. Either way, you're still going to get 5.24. All right, second one. Now my angles in radians. Convert it if you want, or like I'm going to do here, use the new formula, theta equals s over r. What's my angle in radians then if I'm going to use this new formula? 11. It's going to kill me today. 18.
10 pi over 9.
Okay, here we go. 10 pi over 9 in for theta equals arc length, which I'm trying to find, s over 27, r. Go ahead, cross multiply, divide by 9, and we'll see where we go nearest hundredth. $17 when you're ready.
94.25.
Yep. You don't have to use this formula. If you want to convert to degrees and are comfortable using the other one, that's fine. Anything using it right now, because I'm going to use it a different way for numbers 3 and 4. All right, here we go. Find theta now. What is 8? Find the measure of theta. What is this angle measure? I want the answer in radians and I want it in degrees. Okay, I want it in both forms. All right, so let's do it in radians first because I think we're doing that formula today. So theta equals s over r. Is anything going to get plugged in for theta? That's what I'm asking you to find the angle, so just leave it. Theta. What's your arc length? S. Arc length. What is it? How long is the arc here, number 3? 9. We don't have a 9 either. Oh, sorry, Romeo. Bad timing. How long is the arc length in number 3? Just how long is the arc in number 3?
Oh, number 3,
8.
8 pi radians.
8 pi. No. That's not radians. That's centimeters. Right? So that's just 8 pi. That's why I have a little note here. That's the length of the arc. It's just 8 pi, whatever that decimal is, over what's the radius here? 11. Is that the only numbers I have here today? 6? 16. Okay, so there's theta. When I leave your answer in radians, what do I always need it in terms of? Pi. Reduce it. Go ahead. 8 pi over 16 is what pi here? Remember, leave pi in your answer. Don't press it on the calculator. 16 in terms of pi?
1/2 pi.
Yep. 1 pi over 2. So there it is in radians. So that angle's pi over 2 radians. Now I want it in degrees. Now we go to Friday, convert it. I'm not even going to ask here. Convert pi over 2 into degrees. Remember what you got to multiply by. Thanks, Ed. Know what you got to multiply it by. Put it all in your calculator. And let me know what it is in degrees. Five, anything in degrees? What are you multiplying it by?
180.
Okay, so 180 over pi in your calculator times pi over 2 in your calculator.
I don't think I did it right.
What do you put in? You've got a fraction template. Pi over 2 in one fraction template times new fraction template, 180 over pi. There we go, 90 degrees. So in radians, it's pi over 2. In degrees, it's 90. Questions? All right, let's keep grinding. Next one, find theta. Again, I know I should have went over this better. I know there's pi here. That's the length of the arc. Okay, this isn't radians or anything. That's 15 pi over 7 centimeters. That's the length of the arc. So we're trying to find the angle. So theta, length of the arc. What is it? Even though I just said it, but hey, just want to keep people on their toes. Jackson again, 5. What's the length of the arc here in number 4? Here we go. 15 pi over 7. That's your S over your R, which is 5 again. 5. There you go. All right. We're in radians. Leave pi in your answer, right? So take a look. Hey, make sure that pi slips down here. Make sure you slip that pi down. Now in your calculators, 15/7 divided by 5. And leave your answer as a fraction, preferably. So slip the pi down in your answer because it's in radians. And then 15 over 7 on top, 5 on the bottom. I don't know if anybody's done it, but you can do a fraction within a fraction on your calculator. 15/7 over 5. What's it reduced down to? Four. When you have it, let me know.
3 pi over 7.
Good. 3 pi over 7 radians. There it is. There's the angle. Now turn it into degrees, everyone. Turn it into degrees, and I know you're going to get a decimal here, so let's go nearest 10th. Okay, round your answer to the nearest 10th here. Nearest 10th, what do you got for me? 14. 77.1 degrees. There it is. All right. Again, before I move on to some word problems, I can only use this formula if my angle's in what units? Radians. I can only use this formula if my angle's in radians. If it's in degrees, you could use the other formula or convert it so it is in radians. You got your choice. Are we all seriously? Are we all understanding that you don't need to know both formulas? You can know one and be able to convert over. All right? You don't need to know both. You can if you want, that's fine, but you don't need to know both if you can convert. All right, I get nervous when I do this problem every year. We heard of that? Pendulum? That's why I get nervous a little bit. We heard of it? I always do a little visual here. Should have had it ready before, but sorry. Already up here. There we go. Everyone good? Pendulum. This bad boy right here swings back and forth. Some of you may have one at home. I don't know. They're old school, but all good. That's cute, huh? Little elephant and the pendulum's his tusk. That's nice. This would be the answer to guess something that would never be in Mr. Carlino's house. And this would be the answer. All right, that's cute. We got a little mouse hanging down. That's kind of weird, actually, but the way that's kind of constructed. But how much we selling these? Yeah, okay. Here you go. $60. Yep.
I got one stuff.
$60. Yep.
One stuff.
Yeah, I'm gonna be paying $60 for that. Yep. Oh, that's cute. Little fish hanging out. That's the pendulum. Nice. Nice. Oh, look, a little scale and the shark. We ate them. Okay, we all good? Pendulum. Mm-hmm. All right. So if you want to put a little circle at the end here for the pendulum, I don't care. It's up to you. But that's the pendulum right there. It's going to swing back and forth, and the angle that it makes is 2.5 radians. So it's going to swing back and forth somewhere along the circle and make an angle of 2.5 radians. So can you make another pendulum for me? And that forms an angle of 2.5 radians. Right? Everyone see what we're talking about? It goes back and forth, 2.5 radians. And where should I put this 50? Travels through an arc of 50 centimeters. What's the 50? The length of the arc. Yeah, it's going back and forth, and it makes a distance of 50 centimeters. Now, here's where it might get tough. Find the length of the pendulum. Can you put the length of a pendulum into a vocabulary term? We've been talking about this entire unit. Length of the pendulum is the same as asking what of this circle? Zach? The radius length. Everyone agree? Length of the pendulum is another name for the radius of this circle. All right, you individually have a decision to make. We'll make a decision as a class. Do I use the formula that has radians in it, or do I convert radians and then use the other formula? I'm going to use the formula we've been using all today. Is that all right? So I'm not going to convert. I'm going to keep theta equals S over R because my angle is in radians. All right, let's see if we picked anything up today. What are you plugging in for theta? 5. What are we plugging in there, Jackson? 2.5. Good. The angle in radians equals S. What is the S in this case? 11. Yeah. 7. No. 13. 50. Arc length over radius. And we're still going to cross multiply. All right, just put that 2.5 over 1 if you want. 2.5 R equals 50. R equals, how long is that pendulum? 13?
20.
We only got certain numbers here today, huh? 20 centimeters. Okay, all good with the pendulum? Not the last time you'll see that term. All right, let's move it on. Draw yourself a circle. Draw a central angle. Ooh, central angle. Those are what? Angles where the vertex is where? Center. Yep. So draw an angle from the center of the circle. That's 3.5 radians. Go ahead. Do this on your own. I don't care what it looks like. 3.5. It's got an arc length of 24 and a half. What's the diameter? Whoa. My formula only has radius. Can I still use that formula? Yep. Good. Just want to make sure we're straight here. We could still use this formula. Or you could convert 3.5 and solve for diameter in the other formula. Theta, what's going in for theta? 13.
3.5.
Sorry here, Lucy. I'm at the mercy of the generator here. 14. S.
24.5.
Over R. Just make sure when we find R, that's not our final answer. What are we getting for the radius length here? 17.
7.
Yep. And now diameter. We're just going to double that sucker and get 14 centimeters. Yep. Any questions? One more? And then remind me, I need to tell you about how one of the homework problems works. So real quickly, at the top of your page right now, you have both formulas for arc length. One for if it's in degrees, which we used at the beginning of the unit, and one if it's in radians, which I showed you today. All right, so you have two formulas. You do not need to know both. You can use, hey, you like this one? All right, but if it's in degrees, you better make sure to convert it into radians before you use it. Or know both and just use whatever's given to you. Here we go. So it's given us a radius of 2.40 and a central angle of 165 degrees. What's the length of minor arc AB? First, minor arc. Am I looking at the bigger or the smaller one up here? Minor arc. 9, bigger or smaller AB up here?
Smaller.
The one that's less than a semicircle. So this one right here. What's the length of that arc? And look where, hey, calculate using both radians and degrees. I'm going to force you to use both formulas here, just so I can prove a point. All right, ready for it's in degrees, so why don't we just use the degree formula first? That was what, day 2? All right, help me out. Given degrees, length of an arc. 10, given degrees, length of an arc. Formula? Here we go.
The degrees
Which is what now, Josh? Give me numbers here.
165.
Good.
360.
Over 360, good start. Times pi d. What's the 2.40? Radius, so we'll double it, and we'll get the diameter, what's that, 4.8? There it is. So that's in degrees. So right to your calculator right now, we got round to the nearest tenth. Doesn't say in terms of pi, so throw the pi in your calculator, please. We're rounding to the nearest tenth. $17 when you're ready, nearest tenth.
6.9 meters.
Good. So that's using degrees. Now I'm going to force you here. Sorry, I'm going to force you to do it in radians now, which is use the formula from today. Theta equals S over R. Can I just plop in 165 for theta? Plop in 165 for theta? No. What am I going to have to do? Off to the side, take 165 degrees and convert it into radians. All right, so let's review. This is all good review. I'm going to have to multiply that by what? 165 times what? 6. What's my conversion? Times? Pi over 180. Good work. Guys, remember from Friday, leave pi in your answer, right? Leave pi in your answer if it's radians. So this is something pi. I'll let you guys figure that out on your calculator. Leave the pi in your answer if you're giving me radians. Uh, 17. I'm already don't know which numbers. 18. 165 over 180.
Is it 12 over 11?
I think it's,
Other way around.
is it 11 over 12? Yeah, 160, do 165 over 180, and it should be 11 over 12. 11 pi over 12. Can we get that in the calcs? We're good? So that's your theta, because that's your radians now. That's 165 in radians. Equals arc length, S, over radius, 2.40. And watch the magic happen as you cross multiply now. So 12S equals 11 pi times 2.40. Plug it in your calculator. And then get the 12 out of there by dividing. Oh, shocker. As you guys put that in your calculator, what you're getting for an answer. Does it matter what formula you use? Nope, and here's proof. I'm hoping you guys are still getting 6.9 out. Does not matter what formula you use. It's what you're going to be comfortable with. Go to question number 2 tonight for your homework. I'm not going to do it. I just want to make sure we are clear on the directions for number 2. Oh, that is not number 2. There it is. Okay, so for number 2, here's the deal. Every single choice has a radius of 12. That's not going to change for every choice. Now, if you have a radius of 12 and an angle of 120, do the arc length, do you get 8 pi? If you do, we're looking for which one is incorrectly stated the length. So which choice is the arc length incorrect? See what I mean? So for the first one, you have a radius of 12 and an angle of 120. Calculate the arc length. Is it 8 pi? If it's not, there's your answer. If it is, keep moving on. Next one. Now you have an angle of 6 degrees, still with a radius of 12. Is the arc length 72? Everyone see how that works? This one works? I'm giving you a radius of 12 on every one, a different angle for every one. Which one is the arc length incorrectly stated? All good? Okay, go ahead and get started here until the bell rings at least.